Hello students, now we are continuing with electric current through conductors, and now we are going for the topic resistor. You know what is resistance? Basically, it is used to limit the current. Resistance is offered by the conductors, but this resistor is a device. Now this resistor, what we are going to discuss, it is a device which is used to limit the current when it is connected in the circuit. When this resistors we are connecting in the circuit, any circuit, if we want to limit the current, if we want to reduce the current, we are going to connect resistors. We are having two types of resistors. One is wire wound resistors and the other called as a carbon resistors. Basically they are manufactured and it is given the coding of this, the resistors, basically it is given by Electronic Industry Association. And here what we are going to learn is about the device resistor. What is the value of that given resistor? So here we are going to see, to determine the value of the resistors, how to find the value of resistors so that we can use that resistor in any circuit so that to limit the current. Okay, so in any electrical circuit, like if I want to reduce the current, we are going to put the resistors. So we should learn now how to find the value of the resistors. So we can take any resistors, and these resistors are basically recognized by color code. And color code is standard. It is standardized by EIA, that is Electronic Industry Association. Let us go to how to find the resistor, value of the resistors. Now, the resistor is basically a very small device. Okay, you can see the diagram. It is of 1 centimeter, and this is basically you are going to learn about carbon resistors here. There are two terminals here which can be connected, and what will be the value of the resistors. Now in this resistor device, that is carbon resistors, how can we recognize? With the help of the color code. Now where is the color code? Now at one end, that is suppose left hand side, we are having some codes here. We are having some colors. That is band. Now this is one band. Just the second band, the second color will be near to this. Again the third band will be near to this. And the fourth band which is there, it is on the other end of this resistor. Okay, you can see the shape of the resistor. So there is another band. Now what is this band? Now this is the first band, that is first color band. It will give you first digit. It is going to give you first digit. Second band is going to give you second digit. This third band is basically called as multiplier. I will explain you this. And this fourth band is nothing. It is called as a tolerance. We want to find the resistance of this resistor. How much resistance this resistor is going to offer. So with the help of the color code, we are going to find the value of this resistor. So first band will give you first digit, second band will give you second digit, third is called as a multiplier, and fourth band is called as a tolerance. Just see this. There are colors on the resistor, so 4 colors which will give you the value. Okay, now for this we are going to refer it to the table. Okay, what is that table will indicate? Again, here it is basically here we are having color. Here we can write it is first column will be the color code. Okay, the second will be your first digit, that is first band. Then I am writing a second digit. Third I told you it as multiplier. And the fourth one is the tolerance. We will solve this. Okay, so here how we will remember. Just I will give one hint just to remember this color code in a sequence that we will do after this. So how we can just remember the coding of this color code. Here we are having one statement, that is B.B. Roy of Great Britain has a very good wife. So B.B. Roy of Great Britain has very good wife, so that we can remember this color code in sequence. For example, here we are having black, brown, red, orange, yellow, B.B. Roy, B black, B brown, red, B.B. Roy, R.O.Y. Roy, of Great Britain. Great Britain means here it is. We are having green. Britain has, just forget about has, very good wife, very good wife, grey, and this is white. More three colors we can just see here, okay? Just 1 minute. So this is how we are going to remember. That is, here I am writing for you. B.B. Roy of Great Britain has very good wife. Okay. Same thing I am going to write again here. I am just writing for you. Little near. B.B. Roy of orange. B.B. Roy, orange and yellow, of Great Britain, that is green, Britain, that is blue, has very good grey wife, that is white. Okay, and here more three colors. So this, all the colors will be there. Basically it will give you first 3 digits, that is first 3 band for all these colors, and the last band which is at the corner is going to give you, it may be your gold, it may be your silver, and sometimes it may be there is no color in the last band. So for no color, suppose I am just writing no color here. We will see, students, how we are going to use this. We'll come to know how we are going to use. Now how to write the digits of this. Okay. First digits, black means here we are writing 0, brown is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8 and 9. Here nothing is going to come. Gold, silver, no color is basically in the 4th band. So first 3 band is for all this. For all this color will come in the first 3 band. Second digit again it will be same, 0, 1, we are having 2, we are having 3, we are having 4, we are having 5, we are having 6, we are having 7, we are having 8, we are having 9. And third is called multiplier. The third band is multiplier. Like how we write this is, multiplier is 10 is to 0, 10 is to 1, 10 is to 2, 10 is to 3, 10 is to 4, 10 is to 5, 10 is to 6, 10 is to 7, 10 is to 8, and then we are having 10 is to 9. Okay, so here I will just see here. Okay. You can just see what that's making row so that you can see this properly. So that's to 9. Now this table I told you how you are going to buy this. Okay, students. Okay, so here you are going to buy it like B.B. Roy, R.O.Y. Roy of Great Britain has very good wife. B.B. Roy of Great Britain has very good wife. Gold, silver, no color. So till here we are having, till white we are having this basically. This is first three band is going to represent, and last these three things will be, the fourth band will represent gold, silver or no color. Either of this. But tolerance we are having for brown, it is given in the textbook, it is 1% tolerance is there. What is tolerance? I will tell you, it is 2% tolerance is there, and then with gold we are having 5% tolerance, and then we are having 10%, and then we are having 20% tolerance. What is the meaning of tolerance? Tolerance means it is some change in the resistance, ohms. The unit of resistance is ohms. Some small variation is there in the resistance due to temperature, either plus or minus. The tolerance can be therefore plus or minus only 1% or 2% for these two colors, and we are having gold 5%, we are having silver 10%, we are having no color 20%. Okay, so this is how it has to be written. It has to be written in your mind. It has to be again I am telling you now here the something like, if I will tell you, you can easily buy this like B.B. Roy of Great. So let us use a table now. B.B. Roy of Great Britain has very good vibe. Let us use this. Suppose we are having a numerical based on this. Okay, let us see the numerical. Suppose I am telling you we are having a blue, we are having a green, we are having a red, and we are having a gold. Okay. Now these are the four colors. Suppose you go in the market. You go in the market and you will tell, give me some resistor, so that it will be used to limit the current. Give me some resistor. Give me that device of that much ohm. So he will give you that device of that much ohm. So how will you come to know what is the value of that resistance? So it will help you with the help of color code. So color is there. There is a color of bands which is there on that small resistor, 1 centimeter resistor, and then you can decode that. Now let us decode. Suppose we are having four colors here. We are having a color blue, green, red, and gold. First color is your blue. Suppose this is the sum which is there for you in your textbook. Green is the second band. We are having third band is red, and fourth band is gold. First band means first digit, second band means second digit, third band is called multiplier, and fourth band is called tolerance. Let us decode this. Come on. First band, first digit. What is the first digits we are having here according to the sequence? It is the first digit is your first band is your blue. That is your first digit. So where is the first digit? Where is the blue? Where we are having blue is somewhere here. So this will go for the first digit. That is, what is the value of that blue? That is 6. So here we are writing 6. Value is 6. What is the second band? Second color is, second band is green. Second band is second digit. So green. Where is green we are having? Green is second digit we are going to follow. That is green is 5. So we are writing this. 65 is the value. Means 65 ohms. Okay, 65 ohms is your value. Not ohm. It is not clear now. Still 65 is the digits. 2 digits. Now what is your red? Red means your third band. So red is called multiplier. So what is red is multiplier is here. So what is red? Multiplier is this column. So multiply we are having, it is red one will give you 10 to 2. So now this is 10 to 2 we are having. So what you got, it is in ohms. Whatever you are getting, it is in ohms. So first digit, second digit, and third digit is called, as I told you, it is called as a multiplier. Third digit is called as a multiplier. So multiplier you are going to check here. 10 to 2. And fourth is your plus minus. It will give you small change in that resistance. That is gold. I suppose the fourth band is, suppose gold is a color in that. It may be silver, it may be no color, but here we are taking gold. Suppose gold is there. So if gold is there, what is the tolerance of the gold? Here we are having 5%. So what is the tolerance is 5%. 5% of tolerance, okay? So now what is the value? The value is 6500 ohms plus minus 5%, or you can add 6.5. Divided by 1000 is 6.5 kilo ohms ka resistance hai, plus minus 5%. So the value of the resistance, this value of resistance, jiska color code is blue, green, red and gold is 6.5 kilo ohms plus minus 5%. Now what is plus minus 5%? You should know now what is 5% of this you should remove. Suppose if I tell you 10% is how much? It is 10% is 65. So 5% is 65 divided by 2. If you will do, it will be suppose somewhere about 32.5. So 32.5 ohms ka difference it will come. 6532. If you will add this 6532 or 6500 minus 32, you will get the value. So here it is how to plus 5% means you are going to 5% you are going to take for this value. So 6500 ka 5%. So you can add or you can subtract. So just this is just a tolerance. Okay. Now same the second sum we are having. So one more sum I will let you know so that you can easily solve this. You can just make a note of this. Next one is we are having, suppose if you are having in your textbook the another sum which is given to you. Let us take one more sum. Suppose I am taking one more sum for you. Suppose I am taking a sum like which we are taking. Suppose one more resistance. That is we are having yellow, we are having violet. Okay, we are having brown. Suppose I am taking, and suppose I am taking one more silver. Let me see what is the value of this. Okay, now you tell me what is the value of this. So suppose if I am having yellow color. Yellow is my first digit, first band. Yellow is 4 here. It is, I can add 4. What is violet? Violet is my second band. Second. Where is violet now? Violet is second digit is 7. So I'm writing as 7. And third is called multiplier. So into what? 10 raised to brown. Where is brown? Brown is here. Somewhere you can see brown. Brown. What is that? 10 raised to 1. So I'm writing 10 raised to 1. And fourth one is your silver now. Your tolerance silver. Silver is your fourth band. So where the silver tolerance is 10%. So we are adding it is 10% of this. So it is 470 plus minus 10%. It means I can add 4.7 ohms. So it is nothing. It is 4.470 ohms. It is 470 ohms plus minus 10 because yellow we are having again 4. Violet we are having it is 7. Brown we are having it is, where is brown? Brown we are having it is 10 to 1. So it is 10 to 1 plus minus 10% is your silver. So 470 ohms plus minus 10% is your answer. And if you want to write in kilo ohms, you can divide by 1000. So it will come as 0.47 kilo ohms plus minus 10%. 10% is just the change in the resistance. So due to temperature, it can be increasing. 470 ka 10% you are knowing it is 47. It is 47. So 470 plus 47 or 470 minus 47 ohms. So this is I am writing in the ohms. Okay. Once we have seen what is basically resistor and how to find the value of resistors, we will then go for resistors connected in series and resistors connected in parallel. Before that, a small topic we are having, that is about a rheostat. You can see the diagram here. Basically, we are using rheostat. It is basically an adjustable resistor. It is some type of adjustable resistor. We are using this rheostat in a circuit. Suppose Ohm's law. We know basically in Ohm's law we can use rheostat. You know what is the diagram for Ohm's law. Suppose we are having a battery. Which is going to provide you current, and suppose we are having a resistor. External resistor suppose we are having. Okay, external resistors we are having. Always to find current in the resistor we use your ammeter or milliammeter. What is this? How much is the current flowing through the resistors? To find drop across we use voltmeter, plus and minus, always in parallel with the resistors. This is in series with the resistors. Milliammeter. To find current we use milliammeter. To find potential drop across this resistance, across this basically device. This resistance now can be device like bulb or tube light or fan. So what is the voltage drop across this will be given by voltmeter. And then always to vary the current across the resistance we use basically battery. We are going to provide current with the help of battery. But if I want to adjust the bulb, suppose this is a bulb, we are having resistance. If it is a bulb, if I want to glow more, or if I want to reduce the intensity of this bulb, suppose R. So what I am going to do is I am going to reduce the voltage which is provided by the EMF, electromotive force. So how to reduce the voltage is with the help of the rheostat. So rheostat symbol which is there, this is your rheostat. So we connect basically rheostat. So what rheostat does? Okay, what rheostat does? It operates the EMF, electromotive force. So whatever voltage is I want to vary across these resistances, it is operated by the rheostat. So I can vary the voltage. Suppose if I am having the battery, suppose if I am having 5 volts ka battery, okay, 5 volts ka electromotive force across this resistance. To find current, I am going to use milliammeter. To find potential drop, I am going to use voltmeter. But to control this battery, that is rheostat we are using. So it is acting as a potential divider arrangement. Potential divider means it is going to adjust the potential across this potential difference, it is going to adjust with the help of the rheostat. So we are controlling the battery, we are controlling the EMF, electromotive force, with the help of this rheostat. We are having two terminals, and this is the upper terminal. We are talking about this is the upper terminal. We are having one upper terminal and two terminals. This one is open now, and this is connected with the negative terminal. So this is basically rheostat. You can see this part, rheostat. It is used for potential divider arrangement. It is acting as a potential divider arrangement. So it is E is 5 volts, means it is going to operate with from 0. You can give 1 volt also. You can give 2 volt also. To the rest, you can give 3 volt also. You can give 4 volt up to 5 volt, because maximum voltage of battery is 5 volts. So up to 5 volts you can vary this. You can change the EMF of this. So this is your rheostat. Same thing. This rheostat is here. So rheostat is basically an adjustable resistor. Now this is the rheostat. Now here we are having terminals. You can see terminal A, terminal B. So this is one terminal A, one is terminal A, terminal B, two terminals which is there here, and the upper terminal, which is terminal number C. It is this arrow. The arrow indicates the upper. That is variable. It is a variable. You can just slide this. You can see the sliding contact is there. It will just vary from one side to the other side. So this is basically a variable. We have, with the help of a sliding contact, you can just change this. Just slide this sliding contact. Okay, so this is the upper terminal connection. This is with the help of arrow, and two lower terminal as terminal A, terminal B. So in this circuit, we are having terminal A. Suppose it is open. Terminal B, which is connected to the battery. Okay, and here basically it is like a solenoid only. Rheostat is made of solenoid. We are having some block, okay, insulated block, and above this block we are having coil of wire which is wound on this. So this is a rheostat. Okay, rheostat is nothing. It is acting as an adjustable resistor, and you can also change intensity of light. You can control the speed of a motors with the help of this rheostat. Then volume control, you can reduce the volume. You can control the volume of this. Okay. Now its resistive element, which is that this coil of wire which is made, its resistive element can be metal wire, it can be ribbon also, it can be carbon film also. Okay, depending upon different applications they are having. Okay, so this is your rheostat. So basically we are using in many circuits. This is rheostat. See, you can see the diagram of this. Students, we are going for resistance in series. The topic. Resistor in series, or basically we can tell about resistance in series. Okay, it is the same thing, resistor in series and resistance in series. You know what is basically resistor. It is used to limit the current. So wherever I want to reduce the current, I can use one resistor. Suppose I want to reduce more. Okay, so I don't have another resistors, but I am having the same resistor. Okay, suppose if I want to apply 10 ohms, but in the market suppose I am having 5 ohms ka resistor, then what I will do? I will buy two resistance. 5 ohms. But how to connect that resistance in the circuit to reduce the current? So that is basically how we are connecting it. The resistors, we are connecting resistor in series. So what you are going to see is how we are connecting resistors in series. Okay, let us go for that. So here we are having resistors in series. So in any circuit, in any electrical circuit, suppose we are connecting one resistance here, that is R1. If another resistance, if I want to connect that in series to increase the resistance, always to increase the resistance, I have to connect resistor in series. So one end of the resistor will go to the another end of the resistor, that is second resistor. It may be of same value or it may be of different value, but to increase the resistor or to increase the resistance in the circuit, this is the diagram which is for the resistor in series. And then I'm applying a battery here. This is the battery. That is, potential difference will be given by this battery. Now we are not taking a circuit which is where we are going to connect, suppose we are going to connect a lamp or anything. Only we are just studying that what will be the equivalent resistance of these resistors which are connected in series. So we are going to find in this topic is basically equivalent resistance. What is the formula for the equivalent resistance and how it is going to be derived. So let us go for the derivation part of this. Okay. So current will flow through this resistor, both the resistance. How is the current is going to flow? Is it the same current is going to flow through the resistance? Always in series, whenever resistance are in series, the current flowing through them will be same. So current flowing through both the resistance will be same. Same current is going to flow. This is a potential difference will be given by battery. But what you can see here is the voltage drop across this resistor. Suppose this resistor, suppose this is one resistor, this is another resistor. So voltage drop across the resistors will be different. Okay, according to the value of the resistance. Suppose we are having here it is 10 volts. So the drop here can, suppose if it is of the same value, then it will be 5 volts drop, 5 volts drop. Okay. So what basically is going to happen is voltage drop across this resistance will be different. Suppose V1 is a voltage drop across from here to here. Okay. And then here we can take it as V2 will be the voltage drop. So always when the resistors are connected in series, we should know that potential drop across the resistance gets divided. So total voltage provided by the battery will be divided into both this, because there are two resistors. If there are three resistors, then this total voltage of this will be divided into three parts. Now it is divided into two parts because two resistors are there. So here we are writing the voltage drop is V1 across R1 and V2 across R2. But current flowing through both the resistors are same. Current flowing through both the resistors are same. Okay. So according to this diagram, what we are having, the total voltage we are applying with the help of this battery. Total voltage which is across this is divided into two parts, that is V1 plus V2. And what is the total voltage given by this battery? It is what is according to Ohm's law. What is V? V is equal to I into R. According to Ohm's law, V is equal to IR. But we write it as RS. Why RS? Because resistance are in series. Same thing here we are writing what is V1. V1 is nothing. It is current is same. Current into IR1 we write plus V2 is how much? It is IR2. Okay, so current on both the side is same. We can write IRS, which is equal to I. This is R1 plus R2. We are having, and then therefore RS is equal to R1 plus R2. It means in this type of circuit, suppose if we are having two or more resistance, the equivalent resistance will be equivalent resistance of this total effective resistance. Equivalent resistance of this both will be given by RS. That is equivalent resistance is equal to sum of individual resistance. That is R1 plus R2. Suppose I am having 5 ohms and suppose I want 15 ohms resistance. So what I will do is I will connect 5 ohms plus 10 ohms to get 50 ohms. So R1 plus R2. Suppose I want 10 ohms again. Okay, and I'm having two 5 ohms resistance, so I can connect 5 ohms and 5 ohms. So that will give me 10 ohms. So RS is R1 plus R2. So if n number of resistors are connected in series, suppose if there is n number of resistors which are connected in series, if n number of resistors are connected in series, n numbers, all many R1, R2, R3 are connected in series, then what is the equivalent resistance will be RS. If n numbers, then R1 plus R2 plus R3 plus we get dot plus Rn will be the last equivalent. So sum of individual resistances. So total resistances of the circuit will be addition of all the resistances R1 plus R2 plus R3 till last resistance. If you are having more than 2, then you can add 3, then more than 3, 4. So all the resistances it will be added with the help of this formula. So if n number of resistors are connected in series, we are getting RSS, R1 plus R2 plus R3 total of Rn. Similarly, so this formula we can use when resistors are connected in series. Like end of first resistance is going to go to the other end of the second resistance, and again the second resistor will go to the third one. Third resistance will be connected to the fourth one, and then all together they are going to connect. They will be connected to the battery. Okay. Now let us go for resistance in parallel. So same way we will prove it. The formula for resistance in parallel. So now we are going for resistance in parallel. Okay. What is the formula for resistance in parallel? or just writing it, just making it change. Resistors in parallel. Now basically what this is going to do, it is going to reduce the equivalent resistance. Means where suppose if I want to have values of, like example, if I want to get the resistor of 5 ohms, if I want to have reduction of current, or suppose if I want to increase the current, so if I want to increase the current I will decrease the resistance. So suppose I want the value for the resistance as 5 ohms. So if I am going, suppose I am going in the market and if I am going to tell, give me 5 ohms ka resistance, he will tell that I don't have 5 ohms ka resistance. The shopkeeper will tell I am not having 5 ohms ka resistance. So what we will do? He is having 10 ohms ka resistance. So what we have to do is, so I want 5 ohms ka resistance. So what I will do, if he is having 10 ohms ka resistance, I will tell him, please give me 10 ohms ka resistance, but give me 2. So if I am taking 10 ohms ka resistance, 2 10 ohm ka resistance, what that will give you? 2 10 ohms ka resistance will give you the value if connected in parallelly, and how it is connected in parallel, see, it will give you 5 ohms. So that is how we can, we can buy resistors, or we can manipulate, or basically we how we are going to see the connection of resistors in parallel. Okay. Now, so what is basically resistors in parallel? Now, same the diagram where we are just taking here it as, suppose I am having one resistance. The value of this resistance is R1, and if it is connected to another resistor, this is a diagram for that is R2. So you can just see how it is connected. So ends of the resistance R1 and ends of the resistance R2 are connected together. So that is, this connection is called as resistance in parallel. So end of R1 on this side is connected to R2, and end of this R1 is connected to the R2. So this is how it is called as resistors are in parallel, and then it is connected to the battery. It needs battery, EMF, electromotive force. The other end of both, this common end of both the resistances are connected to the batteries. The common end of R1 R2, common end of R1 R2 is connected to batteries. But what you can observe here is current flowing through this is suppose I1, but here what happens at this point, the current gets divided. Suppose your current will get divided because now 2 resistors are there, they are in parallel, so here current will be divided I1, and current flowing through R2 we can take it as I2. Already students you have done in lower standard in 9th or 10th. And what will be the potential drop across this? Now potential drop across this will be same. Potential drop across this will be same because they are the common pointers. So potential drop given by the battery, and it will be same across these points, suppose A and B. But what is different is current. Current flowing through R1 and R2 is different. Resistors are different. Like bulb and tube lights, or current flowings are different. So in circuit also, basically in electrical appliances at home, basically we connect everything in parallel. Okay. So if one resistance, if it is damaged, the other resistance can work. So basically resistance are connected in parallel in this way. Now here we are just seeing that in any circuit, if we are connecting resistance parallel, what is going to happen to the equivalent resistance? It will get reduced. Let us see how we are getting. Now again, according to Ohm's law, here what we are seeing there, in series we are having current is flowing is same because it was in series, and potential drop is divided. Here potential drop is same across A and B, but current gets divided. So here what we are going to take, we are going to take formula for current. What is total current flowing in the circuit? That is I1 plus I2. I1 plus I2. What is your I? Current, total current is nothing. According to Ohm's law, visible IR. What is I? I is V by R. So here we are writing V by R. R, that is we write basically R equivalent. Equivalent means equivalent. That is total I is V by R. So equivalent of that is V by R according to Ohm's. So V is this, and resistance equivalent is equal to what is I1. I1 is we are writing V by R1. V, because V is same, but resistance are different. Okay, so I1 is what according to Ohm's law, V is equal to IR, V is equal to IR1, or I1 is equal to V upon R1. Plus here we write V upon R2. Here same thing, we are writing V, let us go for the V upon R equivalent, that is in parallel. In parallel, here common thing is V, that is 1 upon R1 plus 1 upon R2. So finally V and V will get cut, and resistors providing resistance equivalent in parallel will be, it is 1 upon R1 plus 1 upon R2. This is the formula for equivalent resistance. Okay, 1 upon R equivalent is 1 upon R1 plus 1 upon R2. So if there is more number of resistance which are connected in parallel, again one more R3, one more R4. If suppose there is more number of resistances, if n number of resistors are connected in parallel, like if more resistances are there, suppose something like this, one more resistance is there like this, that is R3, then one more we are having, that is R4. So if more numbers of resistance are there which is connected in parallel like this, we are having okay. So your equivalent resistance will be 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, it goes on plus dot plus 1 upon R. So equivalent resistance is, the equivalent resistance will be given by, the reciprocal of equivalent resistance is the sum of the reciprocal of individual resistance. The reciprocal of equivalent resistance will be equal to sum of reciprocal of individual resistance. So that is how it goes. So 1 upon, if two resistance are there, 1 upon R equivalent is 1 upon R1 plus 1 upon R2. You can take LCM R1 plus R2 upon R1 into R2. So for two resistances, this can be modified. It implies R equivalent is nothing. It is R1 R2 upon R1 plus R2 we can use. And for more resistances, we can use this formula.